Hi guys, today in this example I'm going to look at normal distribution. I'm going to take an example from AQA Mathematics Examination, Unit Statistics 1B, January 2011, question number 6. Let's read the question together. Question number 6. The volume of shampoo V milliliters delivered by a machine into bottles may be modeled by a normal random variable with mu, mean, standard deviation, sigma. The values of mu given 412, sigma given 8. Then we need to find out three conditions here: volume greater than, probability when the volume is less than 400, probability when the volume is greater than 420, probability when the volume is exactly 410. And part B then says that a new quality control specification requires that the values of mu and sigma are changed. So that is a new condition. Probability of volume less than 400 is 0.05 and probability of volume greater than 420 is 0.01. So then we need to show two equations, relations between mu and sigma, and then finally we need to calculate mu and sigma. Okay, let's see how are we going to tackle this problem. So we are given some values mu and sigma, and it says that it is a random normal distribution. So basically in this case we can write the volume V is normally distributed with mu 412 and variance 8 squared. Please note that the value 8 is the standard deviation, therefore variance is equal to standard deviation squared, which is equal to 8 squared. So next problem is that find out the probability when the volume is less than 400. How are we going to look at this question here? So what we normally know is that normal distributions are bell-shaped curves, and it has a mu in the center, and then we normally take the values as x, and in this case the value of x is 412, and then it says that volume less than 400 means somewhere here is 400. So need to find out the area, this area, using our tables. So before we start looking values in the table, we need to convert this x into z. It's a new variable. So what we know is the conversion of x to z is given by this formula. Z is equal to x minus mu over sigma. So using that formula we can find out what is the value of 400 in this case. So 400 will convert into 400 minus 412, that is mu is 412, divided by sigma. In this case sigma is equal to 8, is given 8. So when you simplify this, we'll get a value minus 1.5. Now our task is to find out the area. This is z equal to 1.5, this area. We know our tables actually. So if you look at our tables, in those tables we can see the area is given, z is a positive value always. So we can calculate this area starting from z is equal to greater than 0 here, some value here. But what we have here is z is minus 1.5. So how are we going to tackle this one? Basically what we can do is we can find positive z, that means z equal to 1.5. So that means you read the table and find the area for z equal to 1.5, And also we know that total area is equal to 1. That means the total area under this curve is equal to 1 shaded area plus the unshaded area here. So once you calculate this shaded area using z equal to 1.5, we can find this area, the small area which is unshaded, which is actually by symmetry equal to this area. These two areas are same. So therefore our task here is to find out what is the value area for z equal to 1.5. So we have this table. I think you can take it from your tables given in the exam, and then go down and see the value of z 1.5. So you come down here, so it's exactly 1.5. So the area for 1.5 is given in this given as a number here, 0.93319. So as we just now saw, that is the area of this big area. So therefore our answer should be probability of v less than 400. This is the original variable x. Now we convert it to z variable, but now our task is actually, when we convert directly, we see there's probability v will become z. In this case v is equal to x, so this is our original variable. So and then we have a new variable z. 400 will become 0 minus 1.5. So this is our mathematical value for that, but the tables does not support minus values. So what we did was we found out the symmetric value here. We look at 1.5 and then take away this big area from 1. That means we need to take away 1 minus probability of z less than 1.5. So instead of finding negative 1.5, we find positive 1.5 and find the total area here, big area here, and then take away that value from 1 to find out the value that is this small value, which is equal to this white area. So that means 1 minus 0.93319, which is approximately equal to 0.067. This is the answer to the first part of the question, part A, part 1. Got the point? Okay, let's go on to the second part. So delete all, and we are going to look at this one. So same procedure. Part 2, we are given probability of v greater than 420. Our task is to find the value of z. That means probability z greater than, so again we use the same equation, x minus mu. Mu is 412 divided by sigma. So which gives us a value of probability z greater than 1. So we got a nice number here, z greater than 1. So this is z greater than 1. So how are we going to visualize this condition now? So our new variable is z greater than 1. So we have, so if you want to, it's better always try to visualize what you got here. So originally it was v or x, you can see that x, which was 412 here and 420 here. So what we need to find out is this small area, and when you change the variable to z, and we got, when you change variable z, basically what you do is we change the mu to 0, and then we change to the value for 420 we got is 1 as 1. Okay, so this is actually when you change the variables, you will automatically change your sigma to 1. In this case originally sigma was 8. Okay, now what is our task? So we again bring up the table. So now we need to calculate a value where z is greater than 1. So again the same situation, z is greater than 1 means we need to calculate this area when the value of z is equal to 1. But what we can find it, z is less than 1 from this table, this graph, and then take away from 1. Total area is 1. So what we can write here is that the probability of v greater than 420 is equal to 1 minus probability of z less than 1. So from the table we can find z less than 1. So we take away from the total area to get the white area here. Got the point? So z equal to 1. So you go in your table, go down and find out the area when z equal to 1. So please note that it is exactly 1. If it was 1.1 or something, you just have to go down and find out 1.1. 1.1 is here, 1.11, 1.01, something like that. But in this case 1.000. So therefore that's the first one, 0.84134. That means your answer is 1 minus 0.84134. So that gives us an approximate answer is equal to 0.159. That's how you calculate the probability for volume greater than 420 milliliters. Okay, pretty simple, isn't it? And then let's see the third one, all deleted. So it's a interesting situation where the volume is exactly equal to 410. This is one of the common questions that you might get in continuous variable cases. If you are given a value which is exactly equal to 400 and say some number, 410 in this case, 410. So what is the area under this curve? Basically the question here is that the probability of getting 410 exactly equal to the area under this curve. Basically if it is just a single value, we can't have area. Basically area is 0 under this curve. So therefore we normally conclude that this kind of conditions, we say that probability of volume equal to 410 is impossible, is equal to 0, because there is no area. Whatever number you give, if it is 410, 415, 410, just if it is one value, you can't find area. But if they give an range, if you give a range, say 420 to 421, yeah, there's an area. So we can find the area. But if it is just single value, there is no area. So this is impossible. Therefore your answer should be this is impossible. Since you don't have to write this one, but okay, there is no area at a single point. So that's the conclusion. So in your case you can just write this impossible. That will be the answer to this question. Got a point? Okay, very simple, isn't it? So that's part B, part A, part 3. Okay, we have another part to go, part B. In this case, a new quality control specification is given, and that the values of mu and sigma are changed, and the probability less than volume less than 400 is given as 0.05. Probability volume greater than 420 is given as 0.01. So now in this condition, let's draw a simple picture and try to understand what they say here is that you have this probability distribution, and we have this 412 mean, and this we have this 400. So now they say that the volume less than 400, the probability of volume less than 400 is 0.05. That means this area is 0.05. This is the area. So area of the curve is 0.05. So our task now is to find out the value of z. So we go back to z here. This is my volume or x. Z is the one that we want to find out from the graph. So we need to find out the value of Z. Let's say Z1 and mu equals 0. What is the value of Z1 when the probability when x equal to 400 and the probability is 0.05? Again, we have to do the same procedure here. You take the symmetric value, so find the value of Z1 here. So because this area is 0.05, so if you take this area 0.05, what is the remaining area? Basically we have area remaining which will be up to here and here and here. So this area will be equal to 0.95 because this area is 0.05. So we can again use the other graph, which is actually the percentage points of the normal distribution. So where we can find out the value of Z based on the area. If the area is 0.95, what is the value of Z? So we need to find out the value of Z. This is opposite to the previous case. So we have 0.95. So our probability in this case 0.95. So this is our condition here. So P, or the area, is given 0.95. So this is the line and this is the number. That is the value of Z. So please note that we are going to use the other graph, percentage points graph. Okay, so we found the value of Z now. So it is Z1 here is equal to 1.6449. But actually what we need is the value here, which is equal to minus 1.6449. So which gives us the condition that we can equate this to, we can find out the value of Z1 because we know 1.6449 is Z1, which is equal to x or v minus mu. Mu is unknown and sigma down here. So basically this mu and sigma are new, so that's why they have changed the value. So we got new mu and new sigma. So we can actually see this case as, so if you cross product this one, you will get the first equation. So basically, so when you take sigma to this side, we get 400 minus mu is equal to minus 1.6449 sigma. That is the first equation that that we have to show. That means we found this equation. Similarly, we have the second condition here. So again, we can visualize by using a simple sketch here. So we have the 420. In this case, this is 412 mu, and 420 greater than 420 is here. So the probability when it is greater than 420 is 0.01. Therefore this big area is equal to 0.99. So what we now have to do is go back to the table, because this area is given as 0.99. So what is the value of Z? So we need to find out the value of Z, say Z2 at this particular case. So 0.99 is here, so this is the area, 0.9900. If it is 0.991, you go to the next one. So Z2 can be found. Z2 is equal to 2.3263. So we found Z2. Now we have to do simple thing. Just use the equation Z equal to 2.3263 equal to x minus mu divided by sigma. So that's our conversion. So when you do the cross multiplication, we will get the answer. Basically 400 minus mu is equal to 2.3263 sigma. So we got the answer. This is the answer, second answer. So that's how we calculate the two we use the two conditions to calculate obtain two equations for mu and sigma. Now our task is very simple. It is two simultaneous equations. You need to solve them and find mu and sigma. So our first simultaneous equation is 400 minus mu, which is equal to minus 1.6449 sigma. Question 1, 420 minus mu is equal to 2.3263 sigma 2. So to find mu, so what we do is we take 2 minus 1, 420 minus 400, this will go off, then 2.3263 plus 1.6449 sigma, which will give us sigma is equal to 20 divided by 2 point, so we add these two numbers, so we get 3.9712, which is equal to 5.036. that is the value of sigma. And then substitute in 1 if you want, 1 2, whichever you like. Then mu is equal to 400 plus 1.6449 multiplied by 5.036, which is equal to, you can use your calculator, 408.284. Excellent. That is the answer. It's quite simple. What we have to do is to visualize whatever the values given by using simple sketches, and then try to read the appropriate areas or appropriate values in Z according to the given conditions. Thank you.